Hello, Coach Travis here with another calculus video. So this is a video about the net change theorem. So here's the question. So they give us the graph of f of x. This is the graph of f of x, they say. And then they want us to find the value of the definite integral from -4 to 6 of f prime of x. So don't fall for the trap. So at first, when you see a definite integral, you should say, oh, that's the area under the curve. So you might say, oh, okay, I have to find this area here. But that you got to be careful, because this is going to be the area of under f prime. But this is not the graph of f prime. What we're given is the graph of f. So thinking about this as area would actually be the wrong way to do this problem, because you always have to be clear on what are you given and what are you trying to figure out. So I could try to interpret this as area if I knew the graph of f prime. But the problem is I don't know the graph of f prime. They haven't given me the graph of f prime. So now I could try to find it, but that would be far and away really hard to do, because from experience, if all you have is the graph, finding the derivative is a pretty hard thing to do. I mean, you can estimate it, but finding an exact value is pretty difficult. So what we want to use here is we want to use the net change theorem. So what the net change theorem basically says is it says that if you integrate the derivative over an interval, then you get the net change in the original function. So the idea here is the notation's a little bit different, but the idea is over here, little f represents the derivative. That's what it says. Little f is the derivative, and so in this problem, we have a derivative inside of the integral. So this is saying, okay, if you have the derivative inside of your integral, then the definite integral just evaluates to the net change in the original function. So the moral of this thing here is basically just this. It's that the integral from -4 to 6 of capital F prime of x dx is equal to capital F of 6 minus capital F of -4. That is, if you integrate a derivative, so little f is a derivative, and here f prime is clearly a derivative. If you integrate a derivative, you just get the total change in the original function. And so now we say, okay, well, what's this going to be? Well, now we just look at our picture, and we see that, okay, well, when x is positive 6, then the value of the function is -3. So this is -3 by looking at the graph. And then when x is -4, we get, it looks like -7. So -7. And so the net change here is a positive 4. And so that would be my final answer. So the net change theorem tells us that this integral is actually equal to positive 4. So that's pretty cool in some sense. I mean, we were able to find the area under the f prime function without even knowing what the f prime function looks like. So that's pretty interesting.